Here, Lex lesson here is on 7.5, sum and difference identities for sine, cosine, and tangent. So basically these formulas will be for if we're adding two separate angles. Alpha and beta are angles, so take a moment and write these down. Okay, so our first problem is cosine of 75 degrees. Now, this is not a special angle 75, so we have to use a calculator normally, but there's a lot of preference in math to do things without a calculator to get exact answers. It's more elegant than an exact value. So we can use a sum and difference identity for this. The cosine of 75, we can rewrite that as the cosine of 45 degrees plus 30 degrees. So it would be a sum identity for cosine. 45 plus 30 makes 75. So 45 would be alpha, and 30 would be beta. So we'll write our next step. This equals the cosine of alpha, which is 45. Actually, sorry, cosine, let's start with the sines. So cosine sum identity, the sines are together and the cosines are together. So it'll be sine of alpha, which is 45, times the sine of beta, which is 30. Cosine, a little weird. It's plus here, but in the formula, we switch to minus. Cosine 45 times sine of 30. I'm sorry, times cosine of 30. Again, sines are together, cosines together of each angle. Instead of plus, it's minus. Do our next step right here. Sine of 45 degrees, that's radical 2 over 2. Times the sine of 30, which is 1/2. Minus cosine of 45 degrees is radical 2 over 2. Times cosine of 30, which is radical 3 over 2. Okay. When we multiply these fractions, we're going to get over 4. And multiply these fractions, we're going to get over 4. So we're combining fractions with the same denominator. The denominator is 4, so we can write as a single fraction. This is radical 2 minus radical 6. You multiply radicals, multiply the radicands. 2 times 3 is 6, divided by 4. There's our exact answer. Our next problem, cosine of pi over 12. So we're going to do the same thing, but with radians this time. Okay, we recognize that pi over 12 is not a special radian value. We're looking for radians that are something like pi over 3 or pi over 4, or pi over 6, pi over 2, or a whole pi. So pi over 12 is not going to work, but you can recognize that we can rewrite this as, try this thing, cosine of 4 pi over 12 minus 3 pi over 12. That's the same as cosine of 1 pi over 12. We reduce these fractions. Okay, cosine of 4/12 is 1/3, so it'd be pi over 3 minus pi over 4. These are special angles. We can work with these. So we use our cosine difference identity. The cosine, so it's going to be sine of pi over 3 times sine of pi over 4. And we're not, the negative only tells you what the sign is going to be here. It's not the sine of negative pi over 4, it's sine of pi over 4. Plus cosine opposite signs. Minus here now it's going to be plus. Cosine of pi over 3 cosine pi over 4. Okay? Unit circle time. Sine of pi over 3, it's like sine of 60 degrees. It's radical 3 over 2. Times sine of pi over 4, radical 2 over 2. Plus cosine of pi over 3, it's like the cosine of 60, which is 1/2. Times cosine of pi over 4, radical 2 over 2. We get radical 6 plus radical 2 over 4. Our third problem, we're going to do another one with radians, this time sine. Sine of 7/12. Again, you see radian angle over 12. It's not a special angle. It's not from our unit circle, but we can recognize that you can rewrite it as two special angles that we do know. this will become sine of 3/12 pi plus 4/12 pi. And 3/12 plus 4/12 makes 7/12. Reduce these fractions. Sine of pi over 4 plus pi over 3. So it looks like we're going to get a similar answer to the last problem. A little bit different. Sine sum identity. Okay, so sine has sine and cosine together, and then sine and cosine together. Sine of alpha, let's call this alpha, beta. Sine of alpha, which is pi over 4, times cosine of beta, which is pi over 3. Sine is positive here, it stays positive for sine sum identity. Sine of beta, the other angle now, pi over 3. Cosine of alpha, which is pi over 4. And unit circle times sine of pi over 4 is rad 2 over 2. Times cosine of pi over 3, so it's like cosine of 60, 1/2. Plus sine of 60 degrees would be rad 3 over 2. Times cosine of pi over 4 is cosine of 45, rad 2 over 2. Get radical 2 plus radical 6 over 4. Okay, very similar answer to the last problem, because, let's see, last problem we had cosine of pi over 12. This here we have sine of 7/12 pi. Sine and cosine are co-functions, so I'm not going to talk about it in the video, but it makes sense that we get a similar answer. Something we'll do later in class. Our next problem, we've been given this, and you look at it and see, okay, sine of 80 degrees, cosine of 20 degrees. 80 and 20, those aren't special angles. I don't know those without a calculator. But you do need to recognize, as you see, sine of 80, cosine 20, and then sine of 20, cosine 80, the angles switch, sines and cosines. Oh, that looks like one of my sum and difference identities. Is that one of them for sine? Sine and cosine together, yeah, it's a sine and minus. So that's the same as sine of alpha minus beta. 80 be alpha, 20 be beta. So it's the same thing as sine of 80 degrees minus 20 degrees. It's going backwards using that identity, but reverse order from the previous problems. It becomes a sine of 60 degrees, which is a special angle. Sine of 60 is radical 3 over 2. Our next problem, tangent of 15 degrees. Why don't you go ahead and pause the video and try to do this one on your own using your tangent, sum, or difference identity. So 15 degrees, you need to recognize that 15 is a combination of two special angles. It can be 45 minus 30 or 60 minus 45. Let's go with 60 minus 45. So we have the tangent of alpha minus beta. So from our tangent difference identity, we'll get, that becomes tangent of alpha, which is 60, minus tangent of beta, which is 45, over 1 plus the signs change. If the identity is minus, so it'll be minus first, and the denominator will be plus sign. Tangent of 60 times tangent of 45. Tangent of 60 is radical 3 minus tangent of 45 is 1 divided by 1 plus tangent of 60 is radical 3 times tangent of 45 is 1. Radical 3 times 1 is radical 3. For this unit of our class, normally you should rationalize this times by the conjugate 1 minus rad 3 over 1 minus rad 3, but for our class you can leave it like this.